Vernon, and so Dr. Vernon is Dr. Chen actually. So is a hospital physician who earned his BS in biology from Southern Adventist University and went on to complete his MD at Loma Linda University. He currently works at Kaiser. Kaiser. Okay, so that's okay now. Kaiser Permanente and okay, it's a hard word. Okay, so okay now Emory University. Okay, so okay, that's okay. Sorry for that. So okay, healthcare caring for patients in the greater metro Atlanta area. Dr. Shane has been with us, for almost 2 years now, almost. Yeah, over a year. Okay, over a year, and I really appreciate that. So I'm sure you will be blessed by the presentation by Dr. Cheng and Dr. Lee, and I think so Dr. Cheng will be the first one, and then you will be the next one. We will give you time for Q&A after their presentation. So let's have a quick prayer, and then I will give the time to both of them. Okay, Lord, we thank you very much. You're the God. Wow, Lord, actually, today, actually, so we really have seen a lot, Lord, a lot of time we don't know how to talk with those people in different areas, but Lord, actually, so you want us to know and what they are thinking and what they believe, and then we can share to bridge that. So how can we connect with them? Lord, I thank you for all those presentations. Now we wanted to go to the health science, Lord, and I just want to present this time to you, and may you use Dr. Cheng and Dr. Lee, and when we hear, and I know that you are going to bless the time, we spend next 1 hour, and be with each everyone here, and thank you, Lord, we pray in Jesus' name, amen.
Okay. Well, good evening. I can see that these are the true faithful, the ones that have the ones that have stuck through to the very end. I'll try to keep this as simple as I can. Right. I appreciate all of you being here. My goal is to give a very simplified overview of what I know of our health system, and to also provide the framework for why I believe in creation, and that we are designed by our Heavenly Father. Right. So first is this is a case study of. What I'm using is a case study of the human response to disease, right? Oh, sorry, yeah. So our body does so many different functions, right? That I figured I would narrow it down to one specific system because to show just the complexity involved in it. Cannot be explained by just spontaneous generation. This is something that had to have been thought out and put together in order for our bodies to function. So what I'll be providing is an overview of the intricate and complex systems involved in human immunity to disease. And then I want to make sure that I'll let you know this is very simplified. There are much more orders of magnitude of complexity, in the functioning of our bodies, right? But just in looking at an overview, we can see just how well we work, right? So, because there are numerous specialized cells, hormones that all coordinate our immune response. So, the main thing is that these strategies that the body incorporates, they use it for defense against disease. And when you see how well the body actually defends against disease, in my opinion, it cannot be explained by just spontaneous generation, but provides evidence for a divine creator. So I'm going to give you a perspective of the immune system and what we know so far. So first, the definition. It's an integrated body system of organs, tissues, and cells and cell products that allows us to differentiate between self and non-self, right? With the main thing that self is safe, and then we also need to determine which non-self is benign or safe, and which ones are not safe. Okay, so so this represents the body's defense against things such as organisms, bacteria, viruses, malfunctioning cells. Those are cells that are cancerous. You know, because remember, once your cells are no longer and become cancerous or foreign, right? You have to be able to identify there's something wrong. You know, so so that abnormal cell can be expelled from the body, right? And then as well as foreign particles, right? You know, it's not just living things that can cause problems. It's proteins, pollen, you know, chemicals. So, so where's the immune system located? It's sort of a system that encompasses the whole body, all right? So we have numerous immune cells, known primarily that we call white blood cells, that circulate throughout the body, you know, in our lymph, connective tissues, right? And also they're located and we have little nodules in different areas. Think of them like gateways, right? That are called lymph nodes, right? And those are located throughout the whole body in specific areas, right? So you can sort of call them gatekeepers. And then you have larger parts of the immune system, larger organs that create parts of the immune system. So I broke it down into a more simple form, all right? There's a lot of overlap between these three immune organs. So first one being the bone marrow, where primarily all your white blood cells are made, okay? And a lot of times when they come out from the bone marrow, they're infants. They don't know much. So they're educated in the thymus, right? The thymus is an organ that's located right in the middle of your chest, right? And they sort of educate the white blood cells into different types, give them their jobs. And then the spleen is sort of where they congregate before they are sent out to different parts of the body, right? So how would we classify the immune system? So first we have, you know, overall immunity, and then we have what we call innate immunity and adaptive. Innate means that it's fixed. It doesn't change much. It can't adapt to anything. So those are like walls, you know, walls, stomach acid, sweat, tears. They all contain substances that prevent bacteria and other things from invading the body, okay? So those are our first line of defense, okay? Then you have your adaptive immunity, all right? And then it can be further subdivided into, you know, natural adaptations and artificial. So natural are like things that occur naturally to us. So, and that can be further broken down to passive and active. Passive being we already have antibodies that are already circulating to take care of disease. So natural would be like the passage of antibodies. Okay, it's working now. Natural would be the passive would be the natural passage of antibodies from, let's say, a mother to a child. All right. Active is your own natural response to infection. All right, or active is your own natural response to infection. Then we have artificial. These are things that we do. So passive, we make we generate antibodies such as antivenom. Antivenom is actually antibodies to the poisons that come to us from snakes. And then we also have, and then we have active immunity, which active artificial, which are our vaccines, right? Which vaccines, they allow us to be exposed to pathogens in a safer type of context that we can respond to disease when it actually comes. But we'll get into that more specifically later. So once again, you have your innate immunity. As I said, this is your first line of defense, right? This prevents, overwhelming or tries to prevent overwhelming infection from pathogens. All right, so mucus contains lysozyme, contains chemicals that destroy viruses and bacteria. Cough allows us to expel viruses and bacteria from our body. And our skin contains oils and other chemicals that also have some antibacterial and antiviral properties. Okay, so just drop that. That's an example of a wall, all right, and we are covered in microorganisms that our skin protects us from. Okay, so then we have our adaptive immunity. So these are tailored countermeasures. Okay, and these are specific to foreign pathogens and particles. So the first one, like I said, when you have natural, this is you have your assimilation of exogenous or exterior antibodies from mother's milk, antivenom, poison antidotes. Right? And then you have your body's own response to foreign pathogens by either natural exposure or vaccination. Okay. So what do we need protection from? Well, we need protection from any bacteria, virus, or protein that has potential dangerous effects to our bodies, right? Even something as simple as some molecules can be potentially dangerous as a foreign agent. So something to keep in mind, it is estimated that during our lifetime, we will encounter millions of foreign antigens for which our body will develop a specific response for each. Not only create a specific response, but also remember a specific response, right? This is one of the things that I just can't imagine spontaneously evolved on its own, right? This is something that has been designed. And the interesting thing is that it's not something that's passed on. This is something that your body specifically, right, has come up with during the course of your life, right, based on your exposures. Okay? So the body determines what is safe and dangerous based on, a lot of times, based on exposure context. Okay? So when you think of everything outside around us as all foreign, why is it that we don't react negatively to everything? Well, because depending on the context in which we are exposed, the body can determine whether it is safe or non-safe. All right? So a lot of times we have numerous controlled exposure sites. Okay? We have all throughout our digestive system, we have immune cells circulating, right, that sample the food that we eat to determine what is safe and non-safe. Okay, so because when you eat an apple, you don't develop hives to the apple. You're able to eat, though it is foreign. Okay, so a lot of it has to do with the context in which we are exposed to foreign things. All right, so a lot of those controlled exposure sites are nose, our mouth, eyes. Right? Those are sites with which we interact with the environment that allows us to determine what is safe and non-safe. All right? So any of the bacteria or pathogens that we are exposed to, they are vetted by white blood cells in our lymph nodes, and at that point is determined whether it is safe or non-safe. Okay, if it begins killing cells, that's determined as non-safe, and your body will mount a response. So these are some examples of safe exposure. This is by no means exhaustive. These are just some examples. One is, if you get natural honey that is made locally, right? It contains pollen, right? Which, when ingested, those pollen is sampled by your gut, and then your body determines that based on its context, where it is safe. And then usually what happens is that later on in the year, when that stuff is floating in the air, right? Normally everyone has what we call allergies, right? if you've already been exposed in your gut, your body determines that these are benign, and it's not something it needs to react to. So you're, in a lot of cases, consuming natural honey that is natural to your location, all right, can tone down allergic responses because your body has determined that that pollen is not something to be reacted to. Same thing with, let's say, bacteria from yogurt encountered in the GI tract. So then we have examples of not safe. So let's say you get a cut and then you get some bacteria rubbed into it from dirt. Then, okay, your body's going to say this is not safe. Okay, and then another one is potentially new pollen. You know, let's say you've not ingested pollen or your body has not come in contact to determine the context. Right? If it's encountered in your nasal passages, it can cause an allergic reaction that causes the congestion, sneezing, and all those wonderful things that we call allergies in the spring and summer. All right, so what's real important is that each one of our responses to foreign antigens is timing specific, right? There are ones that allow your body to react very quickly and others that take time. So example, innate immunity is usually immediate. Those are walls, right? Your bacteria come up against the wall, it can't go through it, right? So particularly they're very effective. The only thing is that, they can easily be circumvented, So there are bacteria that they have developed their own countermeasures to our innate walls and chemicals that we use to protect ourselves, right? So examples are stomach acid, expulsion with sneezing or coughing, and so in some cases vomiting. Okay, adaptive passive is slower, but it's pretty quick too. Right, when you already have antibodies that are circulating in your body, those react immediately to the pathogens that they are specific to, right? And within minutes to hours, they can neutralize poisons, bacteria, viruses. They can neutralize them very quickly, okay? But they're not as immediate as wall. All right, and then you have your artificial adaptive, which is a little bit slower than adaptive is slower than passive, right? It takes hours to days, right, for you to develop a response, right? An example of adaptive responses are, vaccines and are vaccines and response to the actual pathogen. So, and then natural adaptive is by far, once again, the slowest. The humoral response can take up to 14 days. So when you come in contact to a foreign object that you've never encountered before, right? To give an example, that foreign object has got to be broken down into its subcomponents, has got to be presented to each one of those subcomponents have got to be presented to specific immune cells which determine biochemical bonds, and then at that point the ones that form the strongest biochemical bonds are then formed into antibodies, and then after that those antibodies have got to be mass produced to billions of antibodies which then circle the body, right? So there are a lot of steps that have to occur in order to develop a response, but once you have encountered, the reason why you're able to respond faster is because your body keeps a library of every single one that you have encountered, right? And that library allows it to say, oh, I know this, and then quickly make millions of antibodies within hours, okay? So I wanted to say that we're truly fearfully and wonderfully made, because when you think about this, okay, billion-dollar research labs take years to develop vaccines against novel infections, okay? With state-of-the-art labs, we were able to develop a vaccine against COVID-19, and it took a year, okay? Prior to that, the fastest vaccine we had developed was mumps, which took 4 years to develop, Okay, so when you look at that, our bodies every day are doing the same thing in as little as 14 days. Okay, so so once again, it's a testament to how well our bodies are made. This is not something that I believe could be, spontaneously generate, right? And even given billions of years, I don't think it could be done. Okay, so but the caveat I need to give is that it's provided we are able to survive that long. As you think 14 days is fast, but when you have an infection, you have to survive 14 days. Okay, so to give an example, pathogenic bacteria grow extremely fast. They double in 4 to 20 minutes. So if you had one bacteria in your body, within 2 hours, that one bacteria has become 1 billion. All right. So as you can see, it can quickly overwhelm our innate defenses, which in the past, diseases have killed millions of people just because, our bodies have not been fast enough to develop countermeasures. All right. So, and I mentioned that earlier. So, to give it I want to give you just an idea of disease in terms of infection. You have an infection and you have your immunity. It's a balancing act, right? And the amount of infection is based on how much bacteria or virus that you come in contact with times the virulence, how dangerous it is. So, if you have a really dangerous bacteria, as many as one can be very dangerous. Like tuberculosis, one bacteria is infective, okay? As opposed to E. coli, which it takes a few million. It's not innately virulent, right? But if you have a whole lot of them around at one time, it's going to cause you some trouble, okay? So, I want to give you an idea of the effects of immune system functioning. When it's functioning good, you have some beneficial effects. One is that it protects you from invaders, elimination of altered or damaged self. But it also has some detrimental effects, right? Immune system functioning can cause discomfort from collateral damage, which is known as inflammation. All right, as well as that inflammation also causes damage to self, and in some cases you can develop hypersensitivity and autoimmunity. Okay, so these effects are modulated, right? Much of our immune system functioning may be modified by adequate exposure to local antigens in appropriate contexts. So when you think about it, in this modern life, right, a lot of times we have eliminated areas in which we can be exposed to local antigens. So when you think about it, what do we eat? A lot of times we eat processed food. Is that food grown locally? No, a lot of times it's grown halfway across the world. So all the antigens that are on that food are from Mexico or from China, right? Which now your body has developed, I know this, but it's like, but I never encounter it, right? One of the best movements that has occurred recently within the last 10 to 15 years has been the farm to table, where people are consuming locally grown fruits and vegetables. The other thing is, when you go to the grocery store, everything that comes from a box that's been sterilized, okay? I mean, you think, yeah, sterilization is a good thing. It means you don't encounter bacteria. Yeah, you don't, but then what happens when you do, right? you have no way to react to it, right? We as much as we'd like to live in an antiseptic environment, an antiseptic environment is not what our bodies were meant to live in. In fact, it's been shown that living in an antiseptic environment leads to actual autoimmunity because your body, it has this wonderful system that's not being used, and it's looking for things to do. So the idle immune system gets into trouble. Okay. So, so by interacting with our local environment, eating local fruits and vegetables, right, it educates our immune system to knowing what is benign versus what is dangerous or virulent, by which we learn to have measured and appropriate responses, right? So as I said earlier, the lack of immune system education leads to complications. The idle immune system is a terrible thing. So these complications are known as hypersensitivity, for which we have an overly aggressive response to benign substances, right? And that results in inflammation and damage to your body, right? And then it also leads to autoimmunity, where now, it's beginning to fight with itself. Things that are, it's now identifying yourself as dangerous, right? Which is not a good thing. So, as I said, adequate education is important. So, our body does not react to food. That's because we've been educated our body's been educated that it's safe. We learned that the body knows the difference between self and others. Right, and realize that without adequate education, we get, education can also cause issues because for transplant patients, because remember, transplant is not self. So how do we try to fool the body into accepting something that's not self? Well, one, you try to find a doppelganger. You try to find someone that looks like you, right? So, like Dr. Lee over there, oh, he looks like Dr. Chin, so I'll let him in, But then after a while, your body realizes, you've pulled the wool over my eyes. He's not you. All right. So then the other things which we also have is that we've developed numerous medications. A lot of the newest medications we have are actually immune modulators, right? That tone down the immune system, sort of put a blindfold over it so it can't see what you're trying to slip something by it. Okay. So in general, you need to realize the immune system is extremely difficult to fool. Okay, so one of the most important tools for immunity is inflammation, right? And it has many beneficial effects. One is once an area gets inflamed, it signals to your body to bring in more white blood cells, bring in the troops, bring them in, right? It also allows your cell walls to create openings so that your body cells can move in. But conversely, it also creates problems because bacteria can also come in through those same openings. All right? It allows for damaged tissue to heal and repair itself, and allows for damaged components to be removed. Right? Now, there are also detrimental effects of inflammation. Right? It causes pain. That's why the best painkillers are anti-inflammatories. What do you do when you stub your foot and it's swollen? You take some aspirin or you take some ibuprofen. What does that do? That takes away the inflammation and takes away the pain. So, prolonged inflammation can cause permanent damage, right? And causes chronic pain. And then chronic stress can wear out, the chronic stress from inflammation wears out the body, using up vital resources and preventing your ability to respond to other diseases and other antigens that you may come in contact with, right? The other thing is that prolonged inflammation can lead to cancer, heart disease, arthritis, and a number of other diseases just because of its chronicity, right? The constant active state of vigilance, right, that stress can lead to all these issues. So how do we manage inflammation? Well, first is you need to manage your health, right? By eating a balanced diet, right, of both raw and locally produced fruits and vegetables is very important for educating our immune system. Focus on mental well-being is extremely important because increased stress from anxiety leads to increased reactivity and leads to inflammation and pain. It is shown that our mental focus and well-being, right, impacts our sensation of pain. All right, depressed people feel their pain far more intensely than those that are not. The other thing is limit activities that can result in injury. Injury can cause lots of issues to our health. And then the other thing is preventive health, such as routine vaccinations, and like I said, exposure to your local surroundings. So the other thing is that when you do have disease, you need to also look for appropriate medication to manage your disease process, because things like elevated blood sugars cause constant permanent inflammation, which leads to disease, which is primarily why diabetics are especially prone to heart disease. And then the other thing is you also look for immune modulators for disorders such as rheumatoid arthritis, lupus, or psoriasis. Okay, this can be a quick primer on vaccination. So you have a lot of different vaccine types. The main goal of vaccines is to expose your body to a given pathogen in a controlled context, such that you develop the response, but not the disease. Okay? So we do this through numerous methods. So the first is inactivated. So that is, you actually take the actual virus or bacteria, throw them in acid to kill them all, and then expose it to the body. All these bacteria are dead, so you should be able to develop antibodies. That's inactivated. So examples are, we have flu vaccines, hepatitis A, polio, and rabies. Those are all inactivated viruses, or inactivated virus vaccines. Then we have live attenuated. These are pathogens that are still alive, but we've injured them enough so they can't hurt you. So it's like you've taken the bacteria and tied its arm behind its back, So now, you get exposed to him, but he can't hurt you, okay? And examples of live attenuated are measles, mumps, rubella, smallpox, and chickenpox. Then we have, these ones are newer ones, which are what we call messenger RNA vaccines. These are ones where we have broken down the pathogen to their genetic origins and then taken the program to actually make a specific antigen or a specific component of that virus or bacteria and allow our bodies to create antibodies to it. All right, so it's highly specific. Okay, and an example of that is COVID-19. All right, our COVID-19 viruses are made from messenger RNA. Next one is subunit, recombinant, polysaccharide, or conjugate vaccines. Basically, all those is that we've now taken one specific protein of a bacteria or virus and made a vaccine from it. So it's not the whole thing, it's just one little piece of it. Okay, and those are, examples are HPV, our pneumococcal and meningococcal vaccines. And then our last one is toxoid vaccines. All right, these ones are, these ones are not, toxoids are chemicals that cause disease in our body. So when you think of tetanus, okay, there's a bacteria that causes it, but it's not the bacteria itself. The bacteria makes a compound, right, that causes the disease, right? So what these are is that they've taken a portion of that molecule or protein that causes disease and expose it to the body that is similar enough to elicit a response, but not enough to cause the disease. Okay, and examples of those are diphtheria and tetanus. Okay. So, as I said earlier, the goal of vaccines is to expose the system to expose you to potential antigens without disease to allow your immune system to develop and react to the real thing, right? Because once you have antibodies circulating, your response to disease is now minutes to hours, right? If we didn't have it, your response is 14 days, right? Which 14 days, a lot can happen. Right? So, but however, there are pitfalls to a lot of our vaccines. One is that not all memory in the body is durable. Sometimes our body can be just like us. You forget things, right? Sometimes your body forgets that, hey, I was exposed to that. I was exposed to pneumonia, and your body's already forgotten it. Other things are these pathogens. They are they're smart. They change. They decide, oh, you recognize my hat, so I'm going to change from a blue hat to a red hat. So now you can't tell what I am, okay? And then the other thing is that sometimes some of these vaccines, they require preservatives in order to keep their molecules stable so that it can be administered. And sometimes those preservatives can cause hypersensitivity. So once again, despite vaccine and medicine development, good health is vital to our well-being, okay? Even though vaccines are great for prevention, right? All vaccines and medicines work best in a healthy body, all right? So we need to first strive to maintain good health. And you do that by eating a balanced diet, eating local food. Next is mental and spiritual well-being, creating strong social and supportive bonds, and taking the time to meditate on God's purpose for our lives. All those things help our bodies function better, okay? Overall wellness is probably the best medicine for our bodies. And then staying active in our community educates our own immune system both to local antigens and keeps our systems primed and ready to work properly, right? Exercise, keeping our bodies strong and resistant to injury and inflammation. And then remember that good health not only protects us, right, but also protects our community. Thank you.
Got the next slide going? Click it. Oh. They're moving it? All right. I can't click it. No control yet. There we go. All right, so now I'm just going to dovetail into a little bit about Dr. Chen's talk. He already talked a little about inflammation already, about immune system, and now we're going to dive a little deeper now. This talk was inspired after watching one of the MedCram show on YouTube. So nothing to disclose. On CME, you have to say nothing to disclose. You have nothing to disclose. So first I have a quote from 1 Corinthians 15:39. It says, all flesh is not the same, but there's one kind of flesh of man, another flesh of animal, another of fish, another of birds. We'll dive into why this is interesting. Because, when you look at meat, it looks like meat, right? Yeah, some meat looks a little different, but they're still meat. But the Bible says they are all the same. And now with scientific proof, they say they are not the same. So first, let's talk about inflammation like Dr. Chen said. So there's acute and there's chronic. So acute is like injury. You cut yourself. What happened? That's body's response to that is swelling, inflammations, redness, some pain there, eventually heals over. And it's done. So that's a good thing because you want to heal your body. You don't want to have to keep cut all the time there. Open avenue for things to come in and attack you. Now, chronic is like, instead of cutting yourself, if you keep picking at your skin all the time, what are you going to expect to happen to your skin there? It's going to go dark, deeper loss of coloration, or maybe even more coloration. You get lots of inflammation there. It's going to look thicker. It's not going to look normal. If you do this long enough, it's going to be permanently problematic. Other forms of chronic inflammation you can see in the biological system would be like Crohn's disease, ulcerative colitis, even like a celiac disease, which is an autoimmune disease where you're attacking your small intestine because you're allergic to celiac. So you make antibody, and your body got confused about the gluten antigen, and start attacking your small bowel, thinking that's the same thing. And it causes, chronic blood loss. It can cause problem with your bowels and terrible things. Also colitis is a terrible disease. Because your body is attacking the large intestine, thinking something's wrong there. And you got horrible pain, diarrhea all the time, bloody stool. You can even cause death if it's not controlled well because it's just a mess. So when inflammation becomes chronic, it is not good for you. And that's why we have all these medicines trying to control chronic inflammation. All right, so my talk now is about sialic acid, which I didn't study very much in medical school. It's a very small compound. So according to the Frontier Medicine, this is their definition, what it does. Sialic acid is a 9-carbon atom sugar that present as a terminal residual of glycoprotein. So these are sugar protein things, or glycolipids on the cell surface that's secreted. And they have important roles in cellular communication and also in role survival and infection of pathogen. So you're like, what? It's just a little molecule. They're not very big. 9 carbons, very tiny. But they cap everything. And these things is actually in the extracellular matrix. Without sialic acid, brain development doesn't work right. So there's disease where people don't make this and they don't do well. If you make too much of it because you don't lack the compound to break it down, it also causes you to be retarded. So something to think about. This is important stuff. It's not very big at all. So sialic acid is the terminal glycan chain for these guys, and it's on all the animal cells. The most common type found in mammal is the Neu5AC. And sialic acid is uniquely mammal, but some proteac has it too, but not as much. And you can see that actually there's a subtype of this one. Sialic acids have 50 different types. Another one is called Neu5Gc, and that's only in red meat and dairy products. The major of sialic acid and glycans to differentiate cell type is to help the innate immune system discriminate between self and non-self also. As a result, different tissue express tens to hundreds of millions of glycan chains that are capped by the sialic acid. And this is where from medical hypothesis, that's back in 2021. So these are a representation of what the sialic acid cap looks like. So you look at it, each cell, they're capped by mannose. And insects don't even have those Neu5AC or Neu5Gc on them. Non-human mammals, you see that they have some 5AC, but also have some 5GC. Now, plants doesn't have any of that. Human, look at that. They don't have anything but 5AC. So, what happens if we do something that has 5GC in it? So, this is the structure. You look at that. It's not very different, is it? This is the 5GC on the middle, and the 5AC is on the right side of the screen. It's only missing an OH molecule on one side. That's it. Not very different there. So, but it makes a whole difference to the immune system. Because, as we said earlier, the human body, we don't have anything but Neu5AC. So, because we lack the enzyme to convert that, so by age 5, you already have make antibody to 5GC. And we ought to talk about that. Antibody causes inflammation. So how does this thing happen now? So this is these guys back in 2008, 2007. They suggested that eating food with 5GC can cause incorporation into the human cell in the epithelial and the endothelia. Those are important places. We don't necessarily want these things to be there necessary. And then here in the Journal of Biological Chemistry, they demonstrated in 2005 by high-performance liquid chromatography that if you eat things with 5GC in it, it incorporates into the cell of the human body, and they could actually demonstrate that in the lab tube. Next is risk of eating things with 5-GC in it. So it can cause chronic inflammation, increased cancer and tissue inflammation. This is from the Frontier of Immunology. And they also found that mice deficient with 5-GC was challenged with 5-GC-rich diet, then injected with the anti-5-GC antibody. There was increased systematic inflammation, and they saw a 5-fold increase in tumor growth. So that's something to pause about. And then this is an interesting one here. This is from the French study. 16,000 adults record 6 different diet records, and they break down the GC amount in the diet, and chicken and fish has no 5-GC. And there's a trend that taking in more 5-GC increases the risk of seeing more 5-GC in the serum. So that's a new study that came in 2020. So this is a breakdown. They actually come with glycemic GC index. They put beef as 1. So you see beef here, cow, 1. They say we'll use that as the standard. And you see some of those cheese are much higher and some are lower. Adventists, we don't eat much rabbit, so we don't have to worry about the rabbit. So it's interesting that certain meat product, even cheese product, have different amount of GC in it. And then we look at this one. The Adventist Health Study, this is Loma Linda, they study all these Adventists for decades. And that's what they came up with. They show that vegan, lacto, ovo vegetarian, pesco vegetarian, semi-vegetarian, non-vegetarian, the BMI go up linearly, and lowest in the vegan, so weight goes up. Weight's going up also increase inflammation. Interestingly, they found that the pesco vegetarian has the lowest risk for cancer. Some people argue that's probably because of the higher omega-3 intake that way. Pesco vegetarian are the people who eat fish and vegetables. They just keep going up. You know, vegan is the most restrictive. And the risk of diabetes goes up also. As you go up from the non-vegan to vegan, they just go up higher. So they say maybe it's due to the intake of salicylic acid intake causes more inflammation. So that's one hypothesis from the Adventist Health Study. So a reversal of inflammation, this guy is a cardiothoracic surgeon. He published in the Journal of Geriatric Cardiology, back in 2017, that you can reverse inflammation. Because what happened was that he saw a lot of his heart patients, they were so sick, they can't have bypass, they won't make it. And his cardiology colleagues say these blood vessel in the heart was in the wrong place. They couldn't stent these people. So these are guys destined to die. And he put all those guys who come to him who was a terminal case that you should be in a hospice. They put these guys on an extremely low-fat vegan diet. And then afterwards, he actually calved them within 3 years of that being on that diet. And it showed reversal of those blood vessels that was so tight that no blood could go through, that now they're wide open. But it is a hard diet. He even came and talked to our church at the Feather River Hospital one time. We invited him to come and talk, and he showed those diet and showed these people doing well. But he said his diet requires you to be vegan, no animal protein and no fat. You don't even cook with fat. But it can be done. The body's a marvelous thing. God made a marvelous, marvelous piece of work that even things that we say, this cannot happen, it can reverse itself. But that's just decrease the inflammation part of it. That helps. And also, if you look at it, there's the outside world has also been now telling us that plant-based diet may be the best for your health, but also for the world. And that's not even from Adventists. This is from the World Health Organization. They published that article about 4 years ago that say, plant-based diet is better for the whole environment and also for human health. because of how bad things are going in the farm industries and things like that. And then if you read the World Cancer Institute Foundation studies, they couple this publishing every 10 years, they update it. So last update was about 2018. They say stuff like a diet based on plants, nuts, beans, and polyunsaturated fat, those type of things, what would increase your likelihood not to get cancer. Because those things all kind of decrease your inflammation. Because when you eat a lot of these 5-GC rich food, your body incorporate this and present it into your endothelium. And they find a higher concentration of 5-GC in cancer cells and also in atherosclerotic tissue. That these inflammations going on, your body's attacking it, is causing more issues going on, which is detrimental for good health. So I'll end with this one, a quote from Ezekiel 36:26 to say, I will give you a new heart and put new spirit within you. Because for us, we're not only fighting to try to keep our body healthy, but also more important, we need to keep our spiritual life healthy. And that's a work of God. And he's a great physician. We're just mild disciple of him in the health industry. But the most important physician is God. Because our spiritual life influences how we live our life with each other and with ourselves. Because spirituality, in the very beginning of medicine, is both physical and spiritual together. But through the Industrial Revolution, the scientific revolution came, we have separated the two. But really, in the very beginning, the role of the priest was both spiritual and also physical. And we're not having enough emphasis on spirituality. But the spirituality of health is a determinant how we experience disease, how we think about it. Because your relationship with God actually affects health positively. There's multiple articles that say people go to church have lower blood pressure, to lower depression. And part of it, they speculate, is because you believe in a higher power. You believe there's someone for you, that you're not alone. And you have a community of people that believe in the same thing, helping each other. That's why there's like the Blue Zone thing. You know, the Blue Zone people, they study all these people. These are people who live over 100 years old in communities. And there's 5 different community studies, and one was in Loma Linda. And part of the study they say is that believing in creation, believing in God, has a positive influence on your life. But also having a strong connection with each other also increases positivity. Because all these things, I think, is part like Vernon said, it's for good health. Because it decreases your inflammation, it decreases your mental health state. It helps you to know that we have a God that loves us. Because when we have that belief system, we know that in our heart, we're less stressed out about what to do about our future. Because we can trust a God who's with us in the past, who's going to be with us in the present, who's going to lead us in the future. So I just end up with the thing that just remember that God is the most important part in our health and our equation. And special thanks to Matt Cram because they inspired me to look at sialic acid.
Much Dr. Lee and Dr. Chen for the presentation. So we are truly fearfully and marvelously created, right? So God really actually gave us a very and actually so this a lot of time we talk about actually when God created us, God also gave each everyone a manual, right? So we really need to follow that. It's kind of manual, huh? And how we can live a healthy life, how can really actually be His representative in this world. And I will leave some time, I think, in a way a little bit early, so we can have about 10 minutes to have a Q&A. And so, do you guys have any question for Dr. Chen and Dr. Lee? And I think. Can you guys back to that? Have any questions? Anyone have any questions to ask?
They're too tired.
They're too tired.
Too tired. But you're good, okay? You're good. Okay, yes. Okay, Kevin, we do have you see.
In response to the lecture on inflammation, a lot of people who struggle with, wanting to have live with a vegetarian diet, they struggle with they ask the question, where am I going to get all my protein from? Like if I don't eat meat or whatnot. What would you say in response to that? And would the benefits from less inflammation, would that be better or worse?
Well, you go first at that.
I'll try to tackle that. Okay, so when you actually say where can you get the protein from, you actually, in the American diet, we have too much protein. So if you look at, say, the energy bar or the protein bar you drink or the protein shake, most of them have more than 15 grams of protein in one serving already. Research has found that when you have more than 15 grams of protein in one thing, you increase the risk of chronic kidney disease down the road 20, 30 years down. Because the kidney is a big organ that needs to process all this extra protein. So that's not that good. And when we have patients who have chronic kidney disease, like stage 3B or 4, the kidney doctor's like, oh, you got to lay off the red meat, your meat size should be the same as your palm size, not as same thickness, and you should limit it because I don't want you to put it on dialysis because it's a miserable experience. So protein is one of those things in the American diet we have too much of in the first place. The other thing is that you can get a lot of protein from just the bean and the legume and things like that. You don't need to eat that much protein to be healthy. So that's one of the things. Now, veganism is a little different because the B12 you will have to find other source of because it's not in the vegetables. You have to go to the yeast and things like that for that part.
And then in regards to inflammation, inflammation is typically good in small amounts, right? Because it is your own body's defense for against infections or against damage that's happened to your body. When you have chronic inflammation, right? Your cells are leaking. Sorry, your cell wall, not your cell walls, but your junctions in your vessels become leaky because white blood cells have to come out. So you begin to have a lot of fluid that goes into your interstitial space. Interstitial space is a space between your outer skin and your blood vessels. So then it begins to get puffy. You end up with cell signaling that's chronically going out there, telling the body to be on high alert. There's something, and that chronic high alert state. Think of it like you go to the airport and they say it's code red because there's a guy with a gun. But let's say there's no guy with a gun, right? What's going to happen is that the TSA is going to find somebody, okay? and it may not be the real terrorist, okay? That's how your body works. When it sits at a heightened state, it is looking for anything. And anything that looks remotely different. Like what you said with the glycolic acids. Anything that looks there, it will react to, right? And those reactions lead to cancer, heart disease, and a multitude of disorders, right? So definitely you don't want chronic inflammation.
Some sources of information say that under normal circumstances, you don't need much protein, but after physical exertion, because excess muscle tissue has been broken down, that the body goes into a catabolic state unless it has a replacement of protein to replenish that breakdown plus a rebuilding. What are your thoughts on that?
That one, I think it just have to be safe and not do overly too much, because then sometimes we do over, because we're just not very good at about judging how much protein breakdown you have. But a lot of people buying these protein shakes and protein things, they're not really being that physical. So then the athlete model is a little different than that. But generally speaking, for the general population, you don't have to use so much, because most of us are not in top athlete condition. But we still buy a lot of these protein shake and protein drink. We would think that's healthier. And it's really not that great for you.
Okay, any other questions? Any other question? Oh, yes. It's testing whether you were sleeping or not, when they are.
Yes, Dr. Chen, I was wondering about this study you was talking about, Dr. Esselstyn, where you said the low fat and no animal products.
That's mine. Yeah, that's Lee.
Dr. Lee, so does that mean, so you're taking away the animal products, so where's the fat coming from? Are you talking about like fat from avocado or nuts, or?
Yes,
No
there are natural fat too. Like you eat coconut, they have saturated fat in it.
Okay.
You use olive oil, they have fat in it too. Some fruits have fat in it. Nuts definitely have fat in it too.
That's a difficult diet. I also wanted to ask about the COVID-19. I know there's some controversy over whether the vaccine was supposed to stop you from being infected or just reduce it. So can you...
Okay. Remember that once again, the way it works is to try to expose you to the pathogen in a safe context, right? Now, albeit it all hinges on your body's ability to react, right? If you are already sick, right, your body may not form a strong enough immunity, right, which still limits you, which still can lead you to infection. The other thing too is that remember the slide. Can you pull up the slide with the balance, right? Where they see the triangle. Remember that the size of the amount of disease, right, is based on the bolus of infection times virulence. Just because you got the vaccine, if you go into a room with a ton of people with COVID-19, your bolus could be so high, you could be exposed to trillions of viral particles at one time that it even overwhelms your immunity's ability to respond. Because now you've put yourself in that you're so horrendously outnumbered that your body can't possibly survive, right? So yeah, so so when you think about it, you need to think about okay, number one, am I healthy? If you're healthy, you'll probably form a really good response, and also realize that after you get the vaccine, the reason why you sometimes feel sick and febrile is not because you got the disease, is because at that point your body is priming itself, right? Your factory is working, right? Sometimes I remember my wife's parents, when she got the vaccine, they thought they got the placebo because they didn't get the fever and the body aches, but in general, that is an evidence that your body's working, right? Not everyone develops those things, but when it is, that is your body priming itself for response to the real thing, okay?
Thank you, doctors, so much. We've learned so much this afternoon. I wanted to ask, there's a lot of people getting sick these days. Kids are out of school, and there's a virus thing going around. What's the best way we can prevent some of these issues that will help us stay well during the winter season?
this season is going to be really rough, right? And it's primarily because of we've been through 2 years of heavy masking, which is good, right? And a little bad. The good thing is that it reduced exposure, right? Well, during that time of reduced exposure, especially children, their immune systems have not been exposed. So what happens when you're not exposed? You haven't learned to respond, right? So what happens is that these children, and especially now being post-COVID, everyone's throwing away the mask, burning the mask, right? So now they're getting really big boluses of virus, right? And they're getting sick. So the best way is would be when you're in large groups of people, it may be a good idea to wear a mask, right? Especially large crowded groups, right? But when you're not, when you're with the family and you're in smaller groups, right? It's good, don't wear it, because that's when your body you might be able to get some good education at that point, right? But but the main thing is you don't want to be over-educated, right?
Another thing is that make sure you get plenty of rest, because if you don't get enough sleep, your immune system won't be primed to fight anything off. And try to stay away from way too much sweetened drinks, because those things cause immune misbehavior. Exercise also helps the immune system too.
Okay, very good. I think this is the time. Unless you have one more question, I will take it. Otherwise, we will just have to close today. So I really appreciate Dr. Lee and Dr. Chen for their presentation. And I know we are going to close tonight at 7:30. We will have another program going on here, but other kids or young people, you would like to have a little activity, and you can go to Absent gym for the gym night over the start at 7:30 as well. Thank you very much. I would like to who can close? Okay, Doctor, can you close with a prayer?
Yeah, bow our heads. Dear Heavenly Father, we thank you so much for your many blessings, that you've created our bodies that are able to learn, respond, and adapt to so many different situations. We also know that you've given us so many ways in which we can maintain our physical, social, mental, and spiritual health. We pray that you'll continue to richly bless us, and to take advantage of the resources we have to promote healthiness as the best evidence of your working in our lives is us having a wonderfully strong and vibrant community, which is a testament to your leading. Once again, we ask that you'll be with each one of us as we go home. Bless us, keep us, and bring us back again to fellowship together. We pray in your most holy name. Amen.
Thank you very much. Thank you. And so you guys are faithful students. We would like to see you guys 7:30 back here. And thank you for joining us. 7:30 we will have a gym night at Absent Church or Absent Gym, and we will have our we're closing here for this creation Sabbath. Okay. Thank you very much. Thank you very much. God bless you.